All right, so here we are for chapter 11, as I said, which is about limits. This is section 11.1, which is finding limits using tables and graphs. Pretty basic here. The goal is to understand the concept. What are we looking for before we go more in depth in the other sections? So our target says I can find and explore limits and their properties. Our purpose today, you'll understand and explore limits through really online activities so that you will have the prior knowledge necessary to be successful in calculus. So I think a big part of this course is getting you ready for calculus next year. So that is something that we are definitely doing with this chapter. All right, so to help you get the big idea of limits, here is an example. So this says, if we increase the number of sides of a polygon, what can you say about the polygon with respect to the circle? So you can see we have a triangle, a square, we have a hexagon, we have a, decagon. As you increase the sides of the polygon, what's happening? Well, this space is getting less and less, right? So as we get more and more sides, we could say it gets closer and closer and closer to being a circle. So if we take this, it is a decagon. I had to count, sorry. If we take this decagon and then we make 20 sides, how much closer would it be to the circle? If we took it to 100 sides. So this says if we talk about the polygon as an n-gon, as n gets larger, it gets closer to being a circle. So if we have a figure with 1,000 sides, picture how close to being a circle would it be? Now, would that polygon actually ever turn into a circle? No, it would not. But would it be so close that it was pretty much a circle? Yes. And that is the idea with limits. Not what is it actually, but is it close enough? Sometimes it actually is. Sometimes we'll be talking about something that is exact. But as we think about a limit, it's getting closer and closer and closer. So this says, you can see in blue here, as n, the number of sides approaches infinity, the n-gon approaches the circle. The limit of the n-gon as n goes to infinity is the circle. So here you can see in notation we're going to use the limit as n goes to infinity. The number of sides goes to infinity of the n-gon is a circle. It is getting towards that circle. So even though it never really turns into a circle, it gets so close that it might as well be a circle. And that's what we're thinking about when we think about limits. So another thought with a big idea, we have this function on the right, x squared minus 4 over x minus 2. If we took the time to graph that, we would see that really it's a line that has a hole at 2. So it jumps over that 2. We know we have to exclude things that would make the denominator equal 0. So that's what would happen here, and it would create a hole. So what happens when I look at that area there? Right? What happens at 2? Picture a little ant walking up towards 2, really close, towards an x value of 2 from the left-hand side. And then picture another ant walking really close to an x value of 2 from the right-hand side. What are both those ants doing? They're getting really close to a y value of 4, the actual value of the function. Now, will they actually reach there? No, sadly, they'll fall in that hole. But do they get really close to 4? Yes, they do. Okay, so if we're looking at this problem, we would say for those ants that the limit of the function as x approaches 2, okay, so as the x value is going towards 2 from the left-hand side and from the right-hand side, the function is going to 4. So here's our limit notation. Okay, what we just wrote out for that example we can see here. So the limit notation, here's what you'll see. The limit of f of x as x approaches a is a number here, equals L, the limit that you find. So the limit of the function as x approached 2 gave 4. The limit of the function, we're talking about the value. When we talk about the actual value of the function, we are talking about a y value. All right, so let's look at that with this graph. This says as x gets really, really big, x gets really big. We're talking about going to the right-hand side. The graph gets closer and closer to, what's that graph doing? It's going towards 0. Again, talking about the y value there. So as x goes to infinity, f of x, the function value, is approaching 0. This is called the limit at infinity. It's written as the limit as x goes to infinity of the function, this is the function 1 over x, is 0. Okay, what's happening now to the graph as x gets really, really small? Picture here, making sure this is our x-axis, this is our y-axis. You know that, I know, but good. So as x gets really, really small, we're going far, far, far to the left. Okay, that is the limit as x approaches negative infinity. Okay, negative infinity is as far left as you can go of the function 1 over x is still 0. That function is still going as close to the x-axis as it can, which is 0. Next question, what happens as x approaches 0 from the left-hand side? All right, now we're going to think about a notation that you saw way back in chapter 2 with Mrs. Francis. So the limit as x approaches 0. Now, how do I say from the left? I put a little minus sign. That does not look like a minus sign. I'm going to fix that. Hold that thought. All right. So what we're saying here, x is going towards 0 from the left-hand side. Think about it. I'm on the left-hand side of 0. I'm going towards 0. What is happening to the function? The function is going straight down. What's straight down? Negative infinity. All right, and then what happens as x approaches 0 from the right? So I'm going towards 0, but from the right-hand side. Look at my function. As I travel the function, it's shooting up. So the limit as x approaches 0 from the positive side, from the right-hand side, is infinity. And then last one about this graph, since the limit from the left does not equal the limit from the right, the limit does not exist. So if I ask the limit as x approaches 0 of 1 over x does not exist. And you could certainly just write DNE. Does not exist. So because the limit from the left and the limit from the right do not match. Picture, if I had an ant walking this way and an ant walking this way, what are the ants doing? Well, they're not doing the same thing, so I can't answer that question. It does not exist. Unlike our first graph we saw, they were walking towards the same number. Here, they're walking towards very different numbers. So since I can't see, I can't answer the question.